Chapter 2, Measurement and Problem Solving. This chapter is really important. Okay, and if you look at the schedule, you'll notice that we're spending a lot of time on Chapter 2. And that's because this stuff is really, really important to grasp, because it's kind of foundational for a lot of other things we're going to be doing. So the first section is interesting and all, but I'm skipping it. So we're going to just go right to section 2.2. I would encourage you to actually, as I mentioned before, read the textbook. There's a lot of extra things in there that I'm not necessarily going to test you on, but they are things that I think should be interesting to you about how chemistry applies to life. I just don't have time in class to go over all of that thing. So we're going to talk about scientific notation. We're going to use scientific notation, and it's really important that we understand how it works and that we know how to do this on our calculators. So scientific notation is used for writing very large and very small numbers more conveniently. Okay, you get a number, like 4 billion or something, and you have to actually almost get your finger out and count the zeros when you look at it. So what is scientific notation? There's two parts to a number that's written in scientific notation. There's the decimal part, and that's going to be a number that's between 1 and 10. And then there's the exponential part, which is 10 raised to a power. So here we have the decimal part, 1.2. So anything here from 1 up to 9.9999999. But there's always one digit and then the decimal point. That's scientific notation. Always, always. And then it's times 10 raised to a power. The exponent here is going to be a whole number. It can be negative or positive. But this is just multiplying this number. So we're either multiplying, moving the decimal point one way or the other way. We're just changing the magnitude of the number without changing what it actually is. So if we have a positive exponent, it means that that number, the decimal part, is multiplied by 10, whatever number of that exponent is. Okay, what on earth? This is getting very confusing. Okay, so here, 10 to the second power. 10 to the second is 10 times 10, 2 times. 10 to the third is 10 times 10 times 10, 3 times. Okay, that's fairly straightforward. The negative means that it's 1 over that. So 10 to the minus 2 is 1 over 10 squared. So let's write on this. So this is the same as 1 over 10 squared. This is the same as 1 over 10 raised to the 1 power. And there's not enough room on this one. This is 1 over 10 cubed. The negative exponent means 1 over. It's the reciprocal. So 10 to the minus 1 is, we're multiplying that by 1 over 10. Or you could say, well, isn't that dividing by 10? Yeah, it is. Dividing and multiplying are just opposites of each other. 1 over 10 is the same as 0.1. 10 to the minus 2 means 1 over 10 squared, which would be 1 over 100, or 0.01. The other, 10 cubed is 10 times 10 times 10, 3 times. It's also, see this number 3? How many zeros are on this number? 3. It's a 1 with 3 zeros. 10 squared, 10 to the second power, is a 1 with 2 zeros. 10 to the first power is a 1 with 1 zero. 10 to the 0 power is a 1 with 0 zeros. You probably don't remember that anything raised to the 0 power is 1. But you can probably remember that 10 to the 0 is a 1 with 0 zeros, no zeros. Any questions so far? So these are powers of 10. So when we're taking a regular number, we say a number in decimal notation, into scientific notation, well, there's the explanation that just comes into my head, and then there's the one on the screen. I'll try to go with the one on the screen. What we have to do, here's this number, 5,983. We need to move the decimal point on this number, and you may say, but that number doesn't have a decimal point. Well, if you were going to put a decimal point on it, where would it be? It'd be at the end, right? So that one would have a decimal point right over here. We understand it to be there. We need to move that decimal point over so that this becomes a number between 1 and 10. So we're going to move the decimal point until it's after the first non-zero digit. So it's going to be 5 point, and then the rest of it, 983. So we move this decimal point over. The exponent is related to how many places we move the decimal point. So we move this decimal point from here to here, that's 1 place, 2 places, 3 places.
Why do you move it 3 places? Sorry.
We're moving it 3 places because we need it to be after the first non-zero digit. It's a good question. So, could you write 59.83? Well, I'd understand what you mean, but that's not correct scientific notation. There's always 1 digit and then the decimal point, always, in scientific notation. So 5.983, and then we write times 10, and the power here, the exponent, is how many places we moved the decimal point. Now, if you have your calculator with you, pull it out. If you don't, and you have one on your cell phone, go ahead and use it for today. Ten to the third is the same as what? 1,000, right? Do that on your calculator. 5.983 times 1,000. What do you get? You get this number back, right? 5,983. So all we've done here, oops, I accidentally changed the color. I guess we'll go with red now. All we've done here is we've essentially factored out powers of 10. We've said 5,983 is the same as 5.983 times 1,000. But we're going to write it in exponential form because when we get to numbers like Avogadro's number, where it's 10 to the 23rd, we don't want to be drawing 23 zeros. It's very tedious. And it's very pointless too because you can't put it into your calculator that way. Okay, so we're learning on these little smaller, more manageable numbers, but we're doing this for the future when we're going to deal with some crazy numbers. So this other example, this is a small number, 0.00034. Okay, for scientific notation, the first digit cannot be 0. So we have to move that decimal point. So we're going to move it this way to the right until we've got 1 non-zero digit. So we're going to end up with 3.4. And then we count. How many places did we move it? We moved it 4 places. So it's 10 to the 4th, but it's negative. Because this is a small number. We're actually dividing out tens. Because if you take 3.4 and divide by 10,000, then you'll get that number back. Because this is 1 over 10,000, right? If you take 3.4 and divide by 10,000, you'll get 0.00034. These are the same number, they're just expressed differently. 4 is the same as 2 times 2. 10 is the same as 5 times 2. Okay, scientific notation is just a method that we've all agreed on where we're pulling out factors of 10. Essentially, we're just moving the decimal point around. Okay? Now, moving the decimal point and counting how many places you moved it, that people don't have much trouble with that. It's how do you remember if it's positive or negative? Is it a positive exponent? Is it a negative exponent? This is what I think is the best way. You look at this original number. Come on, pointer. There you go. 5,983, and you ask yourself, is that a big number or a small number? That's a big number. Would you like it if someone gave you $5,983? I could find something to do with that. Big numbers in terms of money that someone's giving you are positive to you, right? Big numbers are positive exponents. This is a small number, right? It's less than 1. Small numbers get negative exponents. So if it's a big number to start with, it's going to have a positive exponent. If it's a small number, it's got a negative exponent. So let's do some examples. The total U.S. national debt in 2010 was approximately, let's see, 1,000, million, billion, trillion. Is that quadrillion? I don't know. It gets confusing, doesn't it? Okay. We don't need to worry about what to call it. Pardon me?
It's a lot of numbers.
It's a lot of numbers. It's really, really big. That's a number that's so big that we can't really comprehend how big that is. Beside the point. We're going to put that in scientific notation. Now, in that number, where is the decimal point? It's at the end. Okay? So, this is actually a period, but that's where the decimal point would go. So we're going to have to move that decimal point all the way over to the left, and we need to put it after the first non-zero digit. So it's going to be 1.2102. We want to copy down all the non-zero digits. And the zeros, for now, just ignore all those extra zeros. We'll worry about those in a little bit. So we move the decimal point so that this decimal part of our scientific notation number is between 1 and 10, 1.2102. And this is going to be times 10 to the something. And then we have to figure out how many places did we move that. Well, this has commas in it, so we could group by threes. There's 3, 6, 9, 12. We moved it 13 places. So the exponent is 13. And then you ask yourself, is that a big number or a small number? That's a big number. So it's a positive 13. And then I suppose we should put a dollar sign on there, because that's the unit. So that is the national debt from 2010 expressed in scientific notation. Any questions? Let's do this next one. Express the number 0.000038 in scientific notation. We're always moving the decimal point to after the first non-zero digit. So what's the first non-zero digit? It's the 3. So 3, and then we put the decimal point. Oh gosh. Okay, you need to tell me this. You can't see that. It looks really great on my iPad. Really? Okay. Let's go with chalk colored. Okay. So this first one, that's better, isn't it? 1.202 times 10, and then we counted, the decimal point was originally here. We counted 3, 6, 9, 12, 13, and so it's an exponent 13. Sorry about that. I do stuff like that all the time, so you have to let me know, okay? You don't offend me at all. My children have taken care of all of that. So 0.000038, the first non-zero digit is the 3, and so we put the decimal point after that, and then you copy down any other digits after that. So it's 3.8. In this first one, I copied down until I got to the last non-zero digit, and then all the rest of those zeros I dropped off. Notice I did include this 0. Okay, so you just copy down until you get to these guys, and then drop those off. So 3.8, and then this is times 10 to the something. And then we look at the number, and we say, well, the decimal point was here. Whoops. And we go 1, 2, 3, 4, 5. So we moved it 5 places. The exponent then is a 5. And then you ask yourself, positive or negative? Big number or small number? Small number, so it has a negative exponent. Okay? So that is that number in scientific notation. Any questions? Okay. I realized we just need to cover one more thing there that's not really in there. How do you do this on your calculator? That's where this EE button, or some of them have an EXP button, comes in handy. So I'm going to tell you about this, and you can go get your calculator and try this, and maybe try to do some of the homework. So EE or EXP. EXP obviously stands for exponential notation. Scientific notation, exponential notation, 2 different names for exactly the same thing. There's also engineering notation. That's different. I'm not an engineer, so don't ask me about it. I'm not sure what EE exactly means, but your calculator is going to have one of these buttons, not both. And so it gets a little confusing because we've all got different calculators. And then there's a brand of calculators that has times 10 to the x button, which is more descriptive for the student, but I'm never going to mention that one. So if you've got one of those calculators, just know that that's the button I'm talking about when I say EE or EXP. These stand for times 10 to the. Okay? Very common for a student to really understand what scientific notation is and how to work with it, and then miscommunicate with their calculator. Very common problem. So remember that EE or EXP button says times 10 to the. So if you're doing a number like this, 2.79 times 10 to the 4th power. When you enter that into your calculator, these are the keystrokes you're going to use. You're going to press 2 and the decimal point and the 7 and the 9, and then you're going to press that EE button, and you're going to say to yourself times 10 to the, and then 4. It's a shortcut key. The common mistake students make is they'll put in 2.79 times 10 EE4. You've just multiplied your number by 10. And what's really deceptive about that is if you're also dividing by a number in scientific notation, sometimes they cancel each other out and you still get the right answer and you think you're okay, but you're not. So it's very insidious. So the EE or the EXP button is times 10 to the. You put in the decimal part, you press the EE button, and you say to yourself times 10 to the, and then you put in the exponent. Some calculators, like if this was a negative, some calculators will want you to press the change sign button afterwards. Some will want you to change the sign first. They'll want you to put in the minus sign before you put the exponent. So you have to figure that out with your calculator. That's why it's important to have exactly the same calculator for an exam as you've been using all semester, because you don't want to have to fight with a calculator on an exam. Can you do these calculations without using an EE button? Well, I like to use the 10x button. I want to do 2.79 times 10 raised to the x 4. You can, but it's dangerous, because this EE button tells your calculator that this is a single number. It's a single number. And so when we divide that, we don't end up accidentally just dividing the 10 to the minus 4 and not dividing the whole thing. And so there's all kinds of dangerous places and crazy mistakes that you can get into. So just try to do it my way, okay? Give it a shot. If you have problems, please ask me.